Hey everyone, how are we doing? Andrew's here, Kajal is here, Leslie's here, Kristen, Sarah. Good to see you all. Andrew, we've got a new thing this semester. Got to show Andrew the new stuff. Let's do it. Let's go to 1980s. Hacker mode right here. Let's do it. Andrew, we have new awesome effects. We're going to see if this works today. Let's do it. We got to go over here. Let's do it. I think I figured it out. I think I know how to make my car work. Let's hop over there. Let's do this, everybody. Oh, no. There we go. What's up, Garrett? Woo! Let's do this. What's up, everybody? Let's go back to the main screen. There we go. How's everyone doing? Get everyone woken up today. What questions are there? Can you teach my teachers to do things like this? Well, thank you, Andrew. I appreciate it. It's what's scary here. Ayo, what's up, Miranda? Ask questions if you have it. Say, hey, Brian, I'm working on 320. I'm working on 201. Can we talk about interpreting graphs? What graph do you want to interpret, Miranda? We can interpret some box plots. We can interpret some mosaic plots. We can interpret pivot charts. We can interpret histograms, bar charts, pie charts, Pareto plots. We can interpret why my background keeps stopping. Let's do some side-by-side box plots. Background. What do I pay you for background? You do not. There you go. Background's working again. Let me pull up jump right here. Let's get some data sets open. You can't see jump right now, but in just a second, you'll see jump. Where is a data set where I can make side-by-side box plots? Here we go. Let's do this. I need to figure out why. Oh no, Tiny Brian.
I'm Tiny Brian.
Tiny Brian. Fixing Tiny Brian last night, making sure Tiny Brian works. He works perfectly now. We can do that. Okay. So enough about special effects. Let's get serious here. Serious face. Okay, let's do this. So side-by-side box plots. What kind of data does side-by-side box plots take? I need to understand, when do we make side-by-side box plots? Like, this is test relevant stuff. When I ask questions like this, test relevant. Like, when are we making side-by-side box plots? Like, let's understand, what's the point of a side-by-side box plot? What's the deal with side-by-side box plots? How often did Jerry Seinfeld say, what's the deal? What's the deal? What is the deal with side-by-side box plots? I'll be making one in the background while people try to explain what's the deal with side-by-side box plots. You need to go to analyze fit y by x to make side-by-side box plots. Then you need to take a variable that's one of these, one of those, one of these, one of these, something like this. Let's go ahead and go to broken a bone. Let's put it right here. And then let's go to high school GPA and go right here. Now, this is not the one you're making, but I want you to pause and think. Jump's giving you big hints about side-by-side box plots right here. What's going on? It even kind of shows you what the graphic will look like. We're doing this one right here, which is a combination of this and this. Does anyone know when we make side-by-side box plots? Nice job, Miranda. Miranda, you just won 20 points for the class right here. Everyone knows when we get everyone interacting. If you're watching right now live, you got 20 points. Mubot, you awake? Yes, Mubot is awake. 20 points for everyone watching live right now. Hey, thank you, Miranda. So here is kind of, this is just like a dot. It's not really a dot plot. I don't know the name of this. Sorry, here. I don't know the name of this. Sarah's like, yes. I love it. I don't know what this plot is called. It's called a plot. Oh, well, okay. You're not making them this way. You're making them the other way. That's side-by-side box plots. You don't have access to that, Andrew. Dun, dun, dun. Okay, so scratch what I just said. You're going to use Graph Builder. You'll get the same output. We should technically accept it. So I'm going to go here to Broken a Bone. I'm going to go here to high school GPA. This time I'm going to take Broken a Bone and put it right here. You notice it splits it. Does everyone notice the difference between that? This puts it into groups. So now we see the groups of whether someone's broken a bone or not broken a bone. You can also do something. I'll show you a trick, which no graders should take off points for this, but watch this. What? You can add color to it? Whoa. Don't do anything crazy though. Don't like I don't know, this is about the extent of what we can do for this one. We're also going to scroll down here and we're going to go to, let's make it bigger so we can actually see what we're clicking on. We're going to go to 5-number summary. So you don't have to do the color. You don't have to do that. I mean, it's just kind of nice. I don't know. I like it. So we're going to click right there and add the 5-number summary. I'm going to hit done right here. And then I'm also going to take and pull this a little bit that way so the borders are not touching it. This is the final bit. Side, you don't have to do this. Oh, what's broken bone? Okay. You don't have to do that. This is the overachiever. This is the, I've been teaching this class for 10 years. Let me show you what yours probably looks like, which is perfectly fine. I'm going to show you what yours looks like. Here's a trick and jump. We're going to go to redo analysis, and we're going to open the control panel. We're going to remove out, here, let's go to, I'll go to start over. Yours is probably going to look something like this. Yours is going to look something like this. If you want to do the overachiever method, that's perfectly fine. You won't get extra points, but hey, you know, we like doing nice stuff. So yours, where's my 5-number summary? Huh. Maybe I did something weird when I did the redo. Graph builder. Should have 5-number summary. High school GPA, and then we're going to analyze this. We'll talk about what to talk about here. Broken a bone. And now 5-number summary. Where are you at? Where are you at? Am I going mad, everyone? Why is there no 5-number summary? What is going on? Well, wait. No? Summary. What happened? I'm actually confused for a moment. Kristen, you just want everyone another 20 points. Sometimes, like, it's so funny. I do things without even thinking. Kristen, thank you very much. Thank you very much. It's a horrible Elvis impression. There we go. There we go. Yeah, I'm not kidding. It totally jumped out of my mind. You know, I literally did it just moments ago. Everyone's like, Brian doesn't know how to do this. Yeah, I just did it. I just did it moments ago. So I made the real perfect one. And people are like, Brian's joking around. Brian's like, I don't know how to do this. Sometimes you just forget. Sometimes it just jumps out of your head how to do something. Yeah, we did it all yesterday, Maddie. We can do that here next if you're stuck on a specific one. But let me show something right after this, Maddie. I put timestamps in every part of the video for every question last night. So if you look at yesterday's video, it's timestamped with every single question on it. So let me go drop that in the chat here real quick, and I'll show you, and then we're going to interpret this. So yesterday's office hours, we'll pull them up over here. If you look at this video, it is timestamped with every single question. So I'll drop this link in the chat, but you can go to each one, and it kind of has a summary of what each problem is. And so I did every single problem right here. We started with some regression and good stuff like that. So if you want, check this out. But you can also ask a specific one here, but I'll loop back to that here in a moment after we analyze. You're welcome, Maddie, anytime. And it's timestamped, so you can be like, oh, every single problem. We can complete them all. Let's go over here. Let's grab a great screenshot of this. There, did I get? I might cut that edge off of it. Hey, that's a great screenshot. Now remember, this is what you can do right here. This is perfectly fine. This is not your graphic, but this amount of information is perfect. The one on the other side is the overachiever Brian with adding color and all these other things. This is overachiever over here on the far side, and this is what you are expected to do on the right side. So let's go ahead and let's go into a new Word document. And here's Brian's advice for interpreting this graphic. 1, let's talk about center. Let's talk about spread. Let's talk about unusual features. Unusual features. There we go. And we really need to, at all points, compare / contrast and give numbers. Please give numbers. I can't state that enough. If you are not giving the numbers here, then that's very, very bad. So at all points, compare and contrast and give the numbers. So what do I mean by give numbers? Well, let's think about even just one sentence we could write for the centers right here. We are comparing the high school GPAs of those who have broken a bone versus those who have not broken a bone. And what is like something we could say? For people who have not broken a bone, the median or 50th percentile of high school GPAs was 3.85. We can contrast, or comparatively, people who have broken a bone had a similar but slightly lower median GPA, 50th percentile, of 3.82. Does everyone see how I'm comparing the centers? And I mentioned that they're very similar, but this one is slightly lower. The IQRs, and I think I got some, this one's more difficult. Who knows the IQRs for these data sets? The IQRs are the measure of spread of this data set. It looks like the not broken a bone has a slightly larger IQR, so calculate the IQRs right here. We should be pros at calculating IQRs by now. IQRs is the range of the middle 50%. So it's just a range, and it's the range of the middle 50%. So I need one of these IQRs to continue. I'm stuck. Just like I forgot how to make box plots for a second, I forgot how to find the IQR. I'm like, I don't know if I didn't. You are right, Caitlin. Caitlin, thank you so much, Caitlin. You know how to find the IQR. If we ask that question on the test, you will find it immediately. The IQR is 0.48 for this group. So this one has an IQR of 0.480, and this one has an IQR of 0.40. We're just mathematically finding the distance between these points. The IQR is the range of the middle 50%. So we might say that the range of the middle 50% for people who have not broken a bone is 0.48, and the range of the middle 50%, you could say the IQR, which represents the range of the middle 50% for people who have not broken a bone, is 0.48. The IQR, which represents the range of the middle 50% for people who have broken a bone, is 0.40, which is slightly less. The not broken a bone the people who have not broken a bone have the most extreme values with a minimum of 1.8 and 5.0, which are outliers. The not broken a bone group has the most extreme values with a minimum of 1.8 and a maximum of 5.0, which are outliers for that group. The broken a bone group also has outliers, but they're not as extreme, with a minimum of 2.5 and a maximum of 4.75. Does everyone here has outliers which include the minimum and maximum? I might say that. So let me rephrase that. The broken a bone group has outliers which include the minimum and maximum of 2.5 and 4.75 respectively. Does everyone see how I'm walking through, and what am I doing? I talked about the center, spread, and unusual features, and I mentioned the numbers, and I'm comparing and contrasting. Does everyone get the point? How with this 5-number summary up here, we have a lot of things to say. Does this make sense? I think it was Miranda. How are you doing on your interpretation of yours right now? Is it making sense how to compare and contrast the shape, center, spread, or shape? Let me mention something about shape right here. Box plots are not good at viewing shape. This looks mostly symmetric. Why am I saying mostly symmetric? And it's really hard to tell. You don't usually try to figure out the shape of a distribution by a box plot. Box plots are not the best at determining shape. I would say show me a histogram to figure out shape. Histograms are gonna be way better. Yeah. Check it out and tell me what you think. And just to show and ask more questions. We've kind of, or especially, I think it was Maddie. Maddie, if you have questions, especially because these are your guys' office hours. Sometimes I might mention oh, I've done that, but then if we have no questions that we're doing, no worries, Miranda. So have you gone over chapter 3 homework? You know what, Leslie? That's we haven't done that yet, I don't think. So we'll do some chapter 3 homework. I'm going to show right here, I'm going to show how to make stacked histograms, which are part of chapter 4. stacked histograms are chapter 4, so we could look at the high school GPA of people who have broken a bone. This is comparing distributions to quantitative ones. And we also see the box plots right there. And yeah, these distributions were mostly symmetric. So if you see right here, the box plots are above here. This one has a little bit of a left skew, and you don't really see that over here, but they're mostly symmetric distributions. And the histograms are going to give you a better view than the box plots. So just so you can see, this is a bivariate quantitative Y with categorical X. This is a bivariate, and we should add some count axes to these. I'm holding Control or Command on a Mac, and it does it on both. And this right here is a bivariate quantitative Y categorical X. And yeah, so these are stacked histograms right here. Let's do some chapter 3 homework. Let's do it. Let's knock out that homework. And let's get some music going here. Let's get some music. Chapter 3 homework. Here we go. Hop back into space as we get prepared for chapter 3 homework. These interludes help me find where I switch up what I'm doing. I like remind myself, I'm like, okay, wait, do a transition. That way when I edit the video and I put in the timestamps, I can be like, oh yeah, I played this song and I did this thing. It just lets us relax. Let's get to relax, listen to some music. We'll pull up the assignment right here. Okay. I'm currently in my Pearson. I'm about to open the assignment. We won't get to listen to this full song, unfortunately. Chapter 3. There's the quiz. Chapter 3 homework. I like this song. It's just so chill. We were saying Vaporware yesterday. So I've got some songs that sound like that. No more music. Time for music to end. Time to get serious. Here we are with chapter 3. Let me full screen this because I have to go back and forth between stuff. Okay. What do we have here? What is this? It's not really one of those, but no, wrong button. What is that up there? I need to know what this is. I might say it over on the side. I don't see it. What is that? And what does it display? These are the things you should be asking yourself while doing the assignments. What is this thing and what does it display? What is this thing and what does it display? Oh, everyone's stuck. They have no idea what this is up here. Contingency table. Thank you so much, Miranda. Let's throw another 20 points. I don't care if I give out all the points during office hours. Tell people, like, they're short on points. Be like, come to office hours. Ryan gives out points during office hours. It is a contingency table. The contingency table displays bivariate categorical. I almost got it wrong. The contingency table displays bivariate categorical data. You'd have to ask, what was the decision on someone's admission? And Andrew's getting points now. Andrew, we need like maybe fix your 81 hours. Andrew is leading the way on hours. Andrew, let me fix your points really quick. Class is not over. I can't have Andrew's points be like that. Okay. Andrew, check your points again. Just read it. Okay, we're back. We're serious now. Okay. When you're done going over chapter 3, I have a question on chapter 2 quiz. Yeah, Caitlin, feel free to put it in the chat. Yeah, Andrew's hours are real. Andrew Wynn is the best. Sarah, you got to compete with that. Sarah has not had her points inflated. So Sarah's, yeah. Andrew had points and then I reset them. So Andrew did have points and then every semester I'm going to reset the points. Let's get serious with this contingency table. You ready? Here we go. The percent of applicants who are Asian. So this is going to be just kind of an overall percentage right here. Actually, it is a marginal display because we go over here to Asian and you're only looking at this margin. So let me be able to highlight this by copying it. And you're looking at the marginal display for this, the marginal display, which is the display in the margins. So what percent of the applicants are Asian will be these numbers here. It's the display in the margin. So there is what percent of the applicants are Asian. So 452 divided by, there we go. We're going to copy, we're going to paste. It wants it as a percentage. So the best way to do these things is to not like just, you know, don't try to write it, just copy paste it. Always copy paste. Oh, thank you so much, Andrew. I really appreciate that. And White said sat in the front. Oh, which one, Miranda, right here? This one. What percent of students accepted were Asian? Okay, so this is a what display. I pause here because we should know what the terminology is. It just asked for a marginal display, like it only was looking at this area right here. That's a marginal display. So it just had us do a marginal display, and now it wants what percent of the accepted applicants were Asian. So what percent of the accepted applicants? So now we're doing this. I'm going to show the answer here, but what is the terminology for this? We just covered this the last few days. So what percent of the accepted applicants were Asian? And there's the mathematical answer, but what is this called? So given someone was accepted, what was the probability they were Asian? So the answer is going to be, I should be able to do this in my head. So sixth. Oh no, why is my brain not able to do it? I think I can do it. It's like taking a second. I think 0.31666. Why did I mess that up? I was way off. I need to slow down my brain. I don't know 18ths so quickly in my head. So this is a conditional display. Yeah, I was really bad at estimating that. This is a conditional display because it sets a condition. Does that make sense to everybody? This is a conditional display. The percent of students accepted who were Asian, given someone was accepted, what's the probability they are Asian? We're just going to go ahead and round this to 27.8. We're going to break my rules there. What percent of Asians were accepted? This is another what? I want to see in the chat. Just practice right here. What percent of, so given someone was Asian, which, I can't undo that. Given someone was Asian, what's the probability they were accepted? Given someone was Asian. So given someone was Asian, it's looking like I'm highlighting the other numbers, but I'm not. I'm trying to just circle the column right there, or the row. So given someone was Asian, what's the probability they were accepted? So given someone was Asian, what's the probability they were accepted? Anything you can phrase as given makes it a conditional display. So even though it says the percent of Asians who were accepted, you can phrase that given someone was Asian, like for only Asians, what's the probability someone was accepted? And so this would be 50 over 452. That's about 1/9. 1/9 is it's a little bit less than 1/9. So this is going to be, I'm going to guess this one. I think it's going to round up. Yeah, it's that's what 1/9 is, Andrew. So like it's so close that I think you're right. Yeah, it's, see, I was going to guess it. Andrew's right. Nice job, Andrew, right there. Yep. It's basically 1/9. Oh, it's a little bit more than 1/9. No, it's a little bit less than 1/9. Yeah, I know. It's a little bit less than 1/9, and it rounds up. The percent of all students who were accepted. So this is another what? The percent of all students. So now we're going to go to the accepted, and we're looking at the percent of all students who were accepted. This is a what display? Use this terminology to practice. So only look at the thing I've circled. To be very clear, you can barely see this one. Oh, God. We're looking at this right here. So hard to see that thing. So, and that might be the answer. You probably are right, Andrew. The percent of all students who are accepted, 180. That looks to be right. Wait. That looks to be about right. 180 divided by 33. Oh, so let me go back and show that again. So this one right here, the one I'm doing currently, is 180 divided by, and that's the answer. So let's look at the previous one again and review. Let's go back. Ooh, this one's the tough one. That's one people get stuck on. The percent of accepted students who are Asian. So we can phrase this given, so the percent of accepted students. So given someone was, wait. It's the one we're on, right? Yeah, good. No. You're asking about the other one. It moved the questions. So I was like, that's not the one you're asking about. You're asking about, the percent of accepted students who are Asian. Good. So when we do the percent of accepted students who are Asian, we're looking at this, and this is a what display. Thank you so much, Andrew. Oh, wait. I'm totally looking at the wrong one. Sorry. Andrew is right. This one is the percent of Asians who were accepted. So we're going to go here to Asians. What kind of display is this? Andrew is helping out better than me. Brian's adding confusion. What kind of display is this? When I go here and do this, what kind of display is this? So what is the term for this? Who remembers the term for when we do a given? We say like, given someone is Asian, what's the probability? It's a good question because right down here, it says the percent of Asian students. So we're going to say if someone is Asian, so given someone is Asian, conditional, exactly. Great job right there, Kirsten. So given someone is Asian, what is the probability they were accepted? Does that make sense? So they're switching the conditional on these. This one is the condition of being accepted, probability of being Asian. This one is the condition being Asian, probability of being accepted. And this is what it looks like to say, given someone is Asian. So for all Asian students, what's the probability they were accepted? Does that make sense, Miranda? It like switches the, yeah. So just make sure, like when you phrase it, say, given someone's Asian, what's the probability they were accepted versus given someone was accepted, what's the probability they're Asian? So the other way of looking at it in the previous question, the percent of accepted students. So given someone was accepted, what's the probability they're Asian? And this one is this answer right here. So given someone was accepted, what is the probability they're Asian? So it was out of Asians, not the whole total. Exactly. So when we say given, like this says the percent of Asians who were accepted. So you'd say for all Asian students, which this is not currently displaying, but for all Asian students, what's the probability of being accepted? Currently, we're saying for all accepted students, what's the probability of being Asian? So that's a condition like given someone was accepted, what's the probability they're Asian? Does that make sense? Hopefully this helps better understand conditional and marginal displays. Yeah, this is a really great problem on conditional and marginal displays. So yeah, it's just good practice. And then using the terminology and being like, oh, that's a conditional display, that's a marginal display. So if you see words like that on the test, you'll know like, boom, you'll know exactly what those are. Great job. If you followed along, we went pretty in depth on that. And I'm just throwing another 20 points. I don't care. I appreciate all the questions. Slow office hours are the worst, and these are not slow right now. You guys and gals are doing so great with asking questions because just whenever you're stuck, just let me know. Okay, so for chapter 2 quiz, there's a question that says describe the middle 50%, and then the middle 50% falls between. Yes. So the middle 50% is going to be they're probably talking about the IQR. Yeah, that sounds like Q1 and Q3. Yep. And so be careful though, the 50th percentile is the median. And the middle 50%, I'm pretty sure it's just talking about the IQR. If you get it wrong, it's like the only thing you get wrong, just tell me and I'll fix it. I mean, it's whatever. But the middle 50% is the IQR by definition. And this right here is the killer question. You're welcome, Caitlin. Keep up the great work. People starting their work early, practicing. That's what we like to see. So this right here, I want us to just ask 2 questions. You ready? This is how to understand this problem, which this problem is the one that just, it's the killer problem. And I'll be sending people to this part of the video for them to watch. So if you're watching this right now, you probably emailed me and I'm probably like, check this out. But still, email me back if you're stuck. Don't be like, oh, Brian sent me a video and I should, no. Ask more questions. Like, be like, I still don't understand. Would everyone agree? There are 2 things that happen on a given day. There's what you are told the weather will be, and what actually happens with the weather. Does that make sense? There's what, like, is it raining outside right now? And then there's also what was forecasted for today. Like I look at them like, oh, the forecast for today is rain. And I look at them like, oh, it's raining outside. There are 2 things that happen. There is what you are told will happen, the forecast, and then there's what actually happens. Does that make perfect sense to everybody that there's 2 things we should understand? This might be Tennessee's weather forecast, Andrew. It might be. There are 2 things that happen on any day. The forecast, and then what actually happens. So with that understanding, we have 2 categorical variables, and we have, like, were we told it was going to rain today, or were we told it was not going to rain today? Did it rain today? Did it not rain today? Hopefully everyone's on track with that. That sets the stage for the knowledge. So now I want you to look at this. We're going to highlight it to make sense. I'm going to bring it over to Word because we're going to do a lot of work with this. So let's take this, bring it over to a Word document, and understand what's going on right here. We're going to read this up and down and left and right. So when you read this graphic right here and you're trying to make sense of it, we're going to make it really pretty first. Let's go here. Let's bring this in. Boom. We're going to crop this graphic. We're going to bring that right into there. Perfect. Yes, that's the way. Okay, now that we have a nice, perfect graphic, we're good to go. So with this, I want you to look at the actual first. When you see actual right here, this is what actually occurred. Actual is read the following way. So take a moment, don't go too quick, and look at my highlighting. I want you to tell me, be very careful, how many days did it actually rain? Just slow down and just pause and be like, okay, just look at only what I'm trying to help you see right here. How many days did it actually rain? How many days did it actually rain? 34. Because all of those are days, like that column right there represents days where it actually rained, which means if you add up these numbers, you have the days it actually did not rain. Like you look outside and you're like, oh, it's not raining today. This means you look outside and it's not raining. So now let's do the easy one with the numbers, because I'm going to do the easy numbers first. No! Let's go over here and look at forecast. Forecast is read the following way. How many days when you wake up and listen to the weather, so you're going to wake up and listen to the weather, how many days when you wake up and listen to the weather did they not forecast rain? How many days when you wake up and listen to the weather and they're like, today it will not rain? How many days when you wake up and listen to the forecast did they say it would not rain? How many days when you wake up and listen to the forecast did they say it would not rain? Exactly, Kayla. 276. Great job, Kayla, right here. We do stuff like this in 320. Andrew will tell you, if you learn everything through and practice it, it just helps with every class, because statistics is about building your knowledge. We don't do things that are disconnected from other classes. They're 201, 320, 474, 475, 479, 471. They all build. So many 470 somethings. So now I want us to look at one other thing. Can anyone tell me a day, or a total here? Tell me a number where the forecast would match what actually happens. Just tell me a number like 5, which is not on here. But tell me a number where the forecast matches what would actually happen. Tell me a number where the forecast, like when you wake up and you hear it's going to rain, and then it actually does rain that day. So tell me a number where the forecast would match. Like you wake up and they're like, it will rain today. Nice job, Kayla. That's exactly right. Here's where it matches and here's where it matches. This will actually come into play when we do logistic regression and we look at predictions, because logistic regressions will be in what we call a confusion matrix. Exactly. Thank you so much, Andrew. This will be used heavily. And then someone tell me about this day. You woke up. I want you to pretend you live in the fort and you're going to walk to campus. How would you feel this day? What would be your day? I want you to imagine this day, 6 days right here. The 6 that I've highlighted right there, I want you to imagine this day. I just want you to like pretend it happens. You wake up and you hear this. You watch, or you say, "What is the forecast today?" And it's like, "Oh, yeah, okay." And then what actually happens on your day? Those 6 days, what happens? Because if we understand how to read this, we know exactly what it's trying to tell us. I'm using different highlight colors to illustrate these are right predictions and these are wrong predictions. So it's where what actually happens mismatches the forecast for the day. And those would be misclassifications in 320. So for 320, when we use this, these will be the right classifications. These will be the wrong classifications for logistic regression. So hey, if you know how to read this, when we get this in 320, be like, yeah, it's just a confusion matrix. This is a contingency table that shows the classifications of class A versus not class A. So those 6 days over there, I might explain it. Those 6 days right there, you wake up and you hear it is not going to rain. So you hear it's not going to rain, and then it actually does rain. So that's not a fun day. Versus these, it rained exactly. It did rain, and you expected no rain. Versus these 61 days, you hear it's going to rain, but then it does not rain. So you bring your umbrella to campus. Andrew didn't go to class. So you hear it's going to rain. You bring your umbrella to campus, and then it doesn't rain. So let's see how we can do on these questions now. Hey, what's up, Adam? So good to see you here. And let's go. On what percent of days did it actually rain? So there's 365 days in a year. That's another thing you should know for these. It makes the calculating a little bit easier. How many days did it actually rain? Who knows quickly? We did this earlier. Once again, how many days did it actually rain? And if you're wondering how do we get these answers, remember we just covered it all in the graphic right there. So we know how to read it. How many days did it actually rain out of 365? Because 365 days in a year, not leap year. 34, nice job, Andrew. Excellent work. So 34 out of 365. We're just looking at the actual rain right there. And there it is. It wants it as a percentage. So there we go. Does that round up? That's good. Good. On what percent of days was rain predicted? So rain predicted is going to be these two numbers right here. Are we doing chapter 4 in this office hours? Or we could do chapter 4 next, Ella. Do you want? We can finish off this. This is probably the hardest question. Do you want to do some chapter 4 next, Ella? It's your guys' office hours. You get to pick. I've kind of explained how to do all these. Whoa, 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 whoa. What did I do wrong, everybody? Really? Learn how to round. Oh, no. I rounded wrong. What percent of the time was the forecast correct? That's the on diagonal. Not today, my Pearson. I mean, you got me once, but not today. 81.6. That's why I usually copy paste. Please tell me if you're out by one decimal. I'll probably go and correct it. This one is super confusing right here. I already did the homework, just not the chapter 4 quiz. We can do some chapter 4 quiz right after this. Do you want, Ella? Just be like, you can say work this problem, explain this problem, and I'll go into detail and work chapter 4. This graphic down here is the hardest to read. So what you want to read right here is it rained. Yeah, of course. It rained and the forecast was correct. It rained and the forecast was incorrect. So let's go here to where it actually rained. And there are 34 days where it actually rained and 28 it was correct. So 28 out of 34. Here's the 28 days and 34 total. And that's this number right here. So there you go. And does there look to be an association? These differences are very small. So it does not look like there's an association. And we're good to go on that one. This one right here is pretty. I might. We got the placebo one. That one doesn't take long. That one's super easy. Yes, because each genre falls in each category. What's the most common genre? It's hard to see. Oh, least common. Oh gosh, I was like, that's hard to see. And they're gonna show the nope. What's the most common genre? It's gonna be this, the adventure action. And which is it easier to see in? The bar chart. There you go. Bar chart's easier to see. I think should we finish this off real quick? We only have 2 questions. So I'm gonna finish this off right here so we can have this all in here. And then Ella, which one do you want us to do on the quiz? We'll switch over to chapter 4 quiz here. I'm gonna finish this off. This is another contingency table right here. And so let's first figure out if there's evidence. The relapse rate for patients who took antidepressants. So given someone took antidepressants, the relapse rate, does everyone see there are 3 people who relapsed out of the 45? So that's that right there. So 6 point, and it wants 1 decimal, so 6.7%. And the placebo had a much higher relapse rate. Now, here's the issue. Let me point something out. This one looks to have a big difference right here because given somebody took the placebo, they were way more likely to relapse. This is not always going to be the case. I've had people say, Brian, I did what you did and I got it wrong. It's not always going to be the case that there is an association right here because they changed this problem. So don't always click this right here. It depends on the difference. I'd say a difference of more than 10%. I don't know. They usually make it pretty big like this one. And yes, we got it. But in other versions of the problem, it won't always have a big difference. Like in this one right here, there's not a big difference. And that's less than 1% of a difference. So that's very similar. So it's like, yeah, if someone takes the antidepressant, they have a 25% chance of relapse. And if they take the placebo, they have a 24.4% chance of relapse. Andrew, if you're watching, these differences might be due to what? What might these differences be due to? Or does anyone else know? Kayla, do you know what these differences might be due to? Or does anyone in 201 know what these differences in this graphic? These differences might be due to what? They might be due to random chance. What is this say Feb 1st? I'm gonna have to go fix that. I accidentally copied the wrong. Let me go. Can I edit it while we're... Let me go try to fix this. What is today? Feb 3rd. You ever just like not know what day it is? That's my day every day. Yay, 2020. We're still in 2020, right? The stream doesn't say February 3rd, does it? Does the stream say February 1st? Random. Let's do the last question here, then we'll do. Wait, oh no. Okay, this question right here, if you get the quiz version of it, is super easy because it does give you the answers at the end. But this one's not so bad. Relative frequency of accepting a qualified student. So we're just doing univariate analysis. So accepting a student would be this right here over the total. 53.7. Don't make an error. What am I doing? What did I do? I am losing my mind, everybody. The relative frequency of accepting qualified students. I am losing my mind. So let's see right here. The relative frequency of accepting qualified students. There were this many qualified applicants. 1,008 were accepted. Am I losing my mind? So let's go right here. That's how many were accepted. Oh my gosh, did I put in a 7? I really don't know how to round today. My gosh. Never try to speed through assignments. So I get prone to errors. So this is waitlisted. So it's how many were waitlisted out of the total. Very easy to make errors. 17.9. We need a Brian doesn't know how to round thing. Find the relative frequency of qualified students being turned away due to lack of space. So 535 over 1879 and 285. Now, if you get the quiz version of this, the final part of it actually gives you the answers. So you can check it on the quiz very easily. And that's done it. So hopefully if you get that on the quiz, it's kind of a little bit too easy because it gives you the answers at the end. Brian can't round. Let's put that in there. Brian can't round. Okay, let's go here to quotes. Brian can't round. New quote. Brian can't round. You can spam that in the chat whenever I can't round. It should have been 5.37 because, yes, Kayla coming to my defense right here. You know what? Kayla, watch this. Let's go take this and go over here to R because in R, so if you're wondering about the COVID numbers, I looked at the current, I was bored because I don't know, my mind's always trying to spin up and do things, probably a problem. But I was looking at the current rate of decline of COVID numbers, and if we continue at a decline of this was last week to this week, hopefully by about halfway through a year, we should be down under 100. So yay, fun fact of the day. So yeah, that's what happens when I get bored. I just start coding things. See, this is where coding spoils you. Hopefully, all right. That's the way it goes. So let's go right here. And let's take our numbers. Was this it right here? That looks to be it. Let's go to round of this. And let's go to 1 decimal. No, let's go to 3 decimals. Ooh, that's interesting. Even R does it this way. We see that would round up right there. Because watch, if we take this and we go to round of a round, that's just so weird. Oh my gosh, I keep hitting that by mistake. I don't even mean to. Wait a minute. Why is it doing that? My mind. We can't beat the system. R's in on it too. Everything's against us. And the yeah, it makes sense. It makes sense. Like it makes sense to me that you'd round through it. But yeah. I mean, here's the thing. It's like, is it really that big of a difference? Should it really matter? And yeah, I mean, to me, I'm just like, why in the world? It seems like you would just round through this, but it's saying like, no. You know, and I guess that makes sense. It makes sense to me that it wouldn't round up actually now that I think about it, because this is not 0.3565. I actually, maybe, Kayla, maybe that's the way they're teaching it now. And Kayla, you're the math person, so maybe, I mean, it's like, what's the deal with numbers? Numbers are just these weird things that we use to describe reality and put, you know, I don't know. Very interesting. So even R's like, no, because watch this. If I go here to, let's go to value, and let's actually put in this right here. What? You gotta be kidding me. R doesn't round that up? Okay, that's confusing to me. I don't know why R would not round this up right here. But that's weird. Kayla, I didn't know this about R for this until this moment. Let's throw 20 points in the chat. Brian learned something about R. That's worth a 20 points. Yeah, so apparently R will not round up this, which is super weird. Let's just call this value again. Sorry, everyone. We're going to do some more of my piercing in a second. 0. Let's go 3 digits. Yeah, for those who are working in R, that's something maybe we should know. Oh, did we miss something, Rel? Thank you so much. And then I think he has a question too. Ella, I input my data for question 1. Only one of the data sets shows a bar graph. Ella, let me hop back to that. And thank you so much. How did I miss that? So sorry, Ella. Where was that? That might have not showed up in my... Kayla, can you do me a huge favor? And can you screenshot that? Because I don't see Ella's comment on here. It might have not showed up on him. It's so weird. Okay. I input my question for question 1. Only one of the data sets shows a bar graph. It's 15 up. Maybe I just was bad about paying attention. Okay, I'm gonna get serious here now. Was there after the Pearson comment? Let's go take a look at that. Ella, if you're still here, and then he said, I'd like to cue the next question. How do you find the lower quartile and higher quartile with an odd data set? There's 11 numbers. So when you want to find the upper and lower quartile, here's what I would do. 1, we'll never have you find these by hand. So go over to jump right here and enter in the data like 12, 14, 18, 20, 22. You don't have to worry about entering it in order, but go over to jump, enter in the data. Doesn't have to be in order, just to show it doesn't have to be in order. So enter your data into jump, and then go right here and go to Analyze Distribution. So once you've entered in the data under File, New Data Table, File, New Data Table, enter in your data right here. Go to Analyze Distribution, and with Analyze Distribution, double click, and then click OK, and then here you go. So this should give you your quartiles right here of 14 and 28, and yeah, that should do it. That should give you so the IQR here is 14, and this should give the answer to what is the IQR, what is the Q1 and Q3. Yeah, it makes it way easier. It's like, we won't do this. We won't find Q1 and Q3 by hand. So don't worry about finding those by hand. Jump makes it way easy, and then you can also get the median, and you'll know you're correct. You should know how to find the median. Like if you put the numbers in order, if you have 11 numbers, it's going to be 11 things. Now with 11 numbers, let's look at it visually right here. It's going to get mad at me. Open new data set. So with 11 numbers, you've kind of got these data sets divided into 2 parts. So here's another thing you could do. So this one shouldn't be too bad to figure out. Look at this right here. With this data set divided into equal parts, you've kind of got, I'm trying to pull up everything since you one shot. That's the wrong data set. Thank you so much for everyone for catching the question and everything. I think, Ella, if you're wondering, comment more, Ella, and we'll get it figured out. So with 11 numbers, my head right here is the median. But then right here is going to be Q1 and Q3. Hey, Joshua, good to see you. Does this make sense, Hie, that visually speaking, and I've got the data set over there, but with 11 numbers, the third number, which is this one, is going to be Q1, and then the 9th number, which you can see over there, is going to be Q3. I wanted to go back and watch the lecture again from yesterday, but I cannot find the video. Can you help me? Yes. Click the Watch Now Live on Canvas. Hey, Hie, great work right there. So we don't put the links in the chat just because these are unlisted videos, if anyone's wondering. But if you are on Canvas, you should have a button that says watch class live. So go over here. The asynchronous class has two buttons, but if you on Canvas look for watch class live, you will see this button right here, which will bring you to the playlist by clicking this right here. And so that way it's just like unlisted videos that only students can find. Does that make sense right there, Ansley? How to find the playlist. So go to where it says watch class live, click the open a new tab, and it'll bring you to every single class we've had. And there you go. Yes, Ansley, thank you so much. Don't worry. You are not the first person to ask this. People are like, Brian, I can't find the class lecture. Don't worry. Don't worry. I want people to know. Gosh, I can't imagine if someone went the whole semester and was like, I have no idea where the lectures are at. And I understand we do things differently here. So I understand why there can be confusion. Do you go over my peers and quizzes in the office hours or just the homework? I don't have a particular question right now, but I was wondering just in case. Selena, sorry, I missed that earlier. Selena, we definitely go over the quizzes. So you're free to ask. We have a lull right now. I think Ella had a question, which hopefully, Ella didn't add my name. Yeah, that helps me see it really quickly, Ella. Don't worry. And thank you, everyone. Let's throw another 20 points for Vols. Help Vols here. I don't care. We're giving out all the points during office hours. And I really appreciate. Yep. Yep. You can just be here anytime, Selena, and you can just say, hey, can you work this problem? And tagging me helps a ton for me to see the questions. What is the cap on bonus points earned for watching? It just keeps going crazier and crazier. I think we have it up right here that we're going to put. So what you're really trying to get is you're trying to get 2 points on your grade. You're trying to get 2 points overall. And a lot of people are doing insanely well. So if you look at this right now, like Leslie has over 1,000 points, which is awesome. And here we'll do all this question next right here. But what we're going to do is we're going to keep adding new tiers above 2 points. So this is like the tier beyond 2 points. This is the tier beyond this. Does everyone notice it's pretty much 2 points? But why not? I mean, by the time you're getting to the next tier, we're just trying to make new levels for people to get to. These are not the tiers you should care about. This is what you should care about. But then we're also going to have an all-star for each class. So each class will have the highest person in that class. So don't worry, there's just going to be one person. And truthfully, usually the people who get 2 points get an A anyways. So don't be like, I need to get that 2.5. I need the extra 0.5. I need to be the one. Andrew's got like 1,000,000 points right there. Don't worry, Andrew's not currently taking a class. He's at Brian tier. Okay, I usually have classes right now, but we aren't today. Do you happen to know what office hours you covered quiz 2 on? Yes. Let me drop you that link in the chat right here. Thank you so much, Selena, for asking. We went through completely all of it, and I'm going to drop that in the chat. For those who are wondering, we did every bit of quiz 2 yesterday. So let me show you a really great way to find this. A really great way to find this is you see the office hours link right here. So the way this hopefully goes, if I hopefully keep up with it, which I try to keep up with these things every day, is you've got all the office hours in order from when they happen here. So you can see like what day it is, whether it was the afternoon or the morning. I'm gonna drop this link in the chat right here. But the really great thing about yesterday's office hours is, and so here's the link in the chat for yesterday's office hours, is yesterday during office hours, we covered all of the quiz. So you know what this means? You can go down here and you'd be like, oh, I'm working the one about the movies. And boom, here is the movies one. So you see, this is the one about the histogram of the movies. So it shows the runtime minutes of feature films. You could go to another one, be like, oh, I'm doing the one on estimating the standard deviation. So here you go right here, goes right to the estimating standard deviation. You can even hover over and see what we're covering for these different points in the video. So I go through and try to add these timestamps to videos afterwards. Sometimes it might take me up to 24 hours to add them. I do have to like rewatch the video and find the timestamps. So let me know if you ever have questions. Chat, let's see. I think I'm caught up. Oh, here we go. Good. So let me pause this. I have class in 20 minutes. Quick R question. Why do we need so many commas in a paste argument? Example, paste. Let me get this right here. So good question. Then we're going to do Kajal's question next. Is there an office hours where you went over chapter 2 homework? I think so, Kajal. A lot of the chapter 2 homework is a lot like the chapter 2 quiz, and I can find that here next for you if you want. I'm new to YouTube, so I'm learning. Yeah, you're welcome. You're welcome, Selena. Let's go over here. Is the outlier in the data set 1.5 IQRs from the median or from Q3, Q1? It's Q3, Q1. Let me explain that really quick, and then we're going to hop here and do a little R. So the outliers in the data set, I have a graphic to show it. The outliers in the data set are going to be 1.5 IQRs above Q3 and 1.5 IQRs below Q1. So we've kind of graphed it out visually right here. but you would go below Q1, which is right here. There's where Q1 is at. So here's Q1, and you're going to go 1.5 IQRs below it. And the IQR is 6 right here. We've calculated it up here at the top. But it's 1.5 IQRs below Q1, and then the fence where outliers begin is 1.5 IQRs above Q3. So there's where Q3 is, the top of the box. And then we go 1.5 IQRs, which IQR is 6. And we're also showing that graphically up here. Does that make sense, Ella? So this is kind of showing all the mathematics, and we've calculated where the fence is. The upper fence for this one would be at 12.5, which we show. Thank you so much, Selena. Vols help Vols. Let's throw another 20 points. I don't care. Come to office hours. Get all the points. If everyone has top points by the end of semesters, Selena, thank you so much. Vols help Vols. That's what we do. Let's hop back over here to R because we had an R question a moment ago. Okay, so here we go. So right now, Selena has, and this is, or not Selena, this was a question from Kayla. Kayla has a good thing too. Let me grab this question Kayla has here also. Thank you so much, everyone. These are awesome office hours. Sometimes I'm like, I hope people show up. And everyone shows up. I love it. Okay. So, okay. Ooh, that's going to be a complex one. Let me comment that out real quick. Okay. So let's look at this one. We have print, paste on row I and column J. Okay. So what we need right here are I and we need J. Okay. So I and J are now values in the global environment. Just so you can see, I'm going to clear out the global environment. We've now saved I and J to the global environment. Thank you, Selena. And we're now going to paste. We're going to print paste. The print, and this might be a data camp thing. You don't need the print. Let me show you what's going on right here. We should get basically the same thing, if not the exact same thing with the following. So what is going on with these commas? So here's how paste works. Let's explain. How does paste work? So paste joins together all arguments into a sentence, into a character vector. So paste joins together everything you put right there, like pastes it all together. Does that make sense? Paste joins together all of these things into a character vector. So on row, and then you have to change what you're doing right here because this is an object in the global environment. So you could just write right here on row. Here, we'll fix it. So, I mean, this is not fixing it. This is actually breaking it. If you were to take this right here, you would get the exact same output as you just got. But the reason someone would use this formatting instead is because this will interact with these values. So if someone is running some code and wants a return that changes interactively, they want to use the object I. So this breaks right here the character vector that's being created because this is a character vector. And then the next thing that'll be pasted into it is the object I here in the global environment. And then we're pasting in another character vector, and then we're pasting in the object J. So every time you do a comma, you're doing this mainly because you're switching between a character vector being pasted together with an object in the global environment. So hopefully, does that make sense right here? I think it was Kayla asked that too. Does that make sense, Kayla? Got it? Awesome. And then the other question, and great questions. I love doing this kind of stuff. Okay, is it why is, let me see this one. Ooh, see, I love, you guys test my knowledge because I'm like, okay, ooh, it's about the trim and about the character. Let's find out. Okay, this one looks complex. Okay. Why if character, okay, equals u, but I equals 5, 3, what is the trim function? I don't understand. Okay, so the trim function is an argument. So let's do what is trim first. What is trim? Unless there's a trim function. Good, there's not a trim function. So the trim is an argument, and I'll explain why trim is an argument. So are you talking about this right here? And let's get a vector of numbers. So let's just do numbers right here. And let's do numbers 1 through 100. And I think you're referring to this. Are you referring to, yeah, and it looks like you're saying yes, that this is what you are referring to right here. And what is trim? So trim might make a little more sense if I do a different vector. And let me do the following vector of numbers. Let's do the number vector here, 1, 5, 6, 7, 8, 10, and 100. I'll probably need more numbers. Let's go right here. This is an example of why we would trim a vector. So this vector here has a very what in it. This vector right here has a what. this vector right here has a very extreme what? Like just looking at the numbers, and if we look at the histogram of it, it has a huge outlier. This vector has a extreme outlier. This is a somewhat, if I do make this 4, this should be we can quickly look at the histogram. It's so easy to make a histogram inside of R. Like if you make a histogram, all you have to do here is go to hist and go to numbers, and you gotta learn how to spell numbers. Figure too large. There you go. There's the histogram. And you can see the extreme outlier behind my head right there. You can even go to stem and leaf. So there's the stem and leaf right here. Bin widths of 20, and here's all the values here, and there's the extreme outlier. So it's pretty easy to see that this is a very, very skewed distribution. So now when we talk about what does a trim do, we can kind of manually think about a trim right here. So it's like a trim. Just think about what a trim does. So wait, I just want us to think, what do you think trim does to data sets? What do you think trim does? That's more than a trim if I do that. This is a trim. What do you think trim does to a data set? What will trim do to a data set? That's the big question. And it might remove outliers. Trim is going to go to the ends of a data set and remove data on each side. And I'm pretty sure I understand mechanically how trim works, because sometimes people teach it in a little different way. When you talk about a trim right here, you're going to trim from each side of it, and this is the amount you're trimming. So that would be the amount you're trimming from each side of the data set. So you don't usually do big trims on data sets. You might trim 5%, 10%, but trims are going to be a more robust, which means they deal with outliers. So that's a terminology sometimes you hear in statistics, is robust. It means like is going to be okay with outliers. Like a non-robust method is going to be influenced by outliers. So what's a robust method? The mean or the median? The median is more robust to outliers. So trim 10%. I'm pretty sure it trims 10% off each side. I'm pretty sure about this. I'm pretty sure if you ask for trim 10%, and I'm going to confirm this, I just don't use trim that much. And I swear the way I was taught is the opposite. If you ask 10%, I'm pretty sure it's going to do this. So here's what we can do to test this. To test this, let's make a data set with 10%, 10 numbers. We're going to make a 10 number data set. Or let's make a 20 number data set, because then we can test 5%. So we need a 20 number data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers. And let's just copy these numbers again right here. And there's a 20 number data set. So we now have a 20 number data set. So what we're going to do right here is we're going to put 100 right here. And then we're going to put a ridiculous number over here. Boom, 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 boom. So if it is trimming 5%, what should the mean be close to? When we trim 10%, if it's trimming 5%, what should the mean be close to? If it's trimming 5%, it would still include this. Does that make sense? If it's trimming 5%, it'll only trim off this number and this number. Does that make sense, Kayla? If it's trimming 5%, these are the only numbers that'll get trimmed. So if that's a 5% trim. If it's trimming 10%, then both of these numbers will be removed. So if I do the mean and we get it, which I'm pretty sure we're going to get a number of like 6, 7, something like that. Let's see. The answer is, do we get 6 or 7? The answer is, there we go. It is doing what I said. It is trimming off from both sides 10%. So when you ask for a trim of 10%, it takes 10% from both sides. So I don't use this one that much, so I had to think. I'd be like, how does that? Like I know what it does, but I'm just like, okay, exactly what is it doing? So it's trimming off exactly 10% from both sides. So we can also confirm this by asking for a 5% trim, and we should still include the 1,000, which is going to greatly inflate the mean. So because of the 5% trim would not remove off this value. And these are basically 2 data sets, and you're trimming off, like this is trimming off 1 value from each side, or 1 value total. For quiz 4, and then let me see, and we'll do that next here. Great question, Ella. I think there was one more I have from Kayla right here. Don't worry. Ask the questions, because we're definitely at a point where I need more questions. If character equals u, but x equals okay, this is the second one right here. Okay, wait. I might need more details on this one. Okay, we got a logical check to see if a character. Let's store into character. Can you explain more detail on this one? We're gonna go care, and we're gonna put in u right here. Y equals for characters, but oh, I know why. Okay, let me explain. This is where Datacamp's tricking you, because you probably saw this on Datacamp. So good question. Anytime you see equals, what's going on right here? So anytime you see equals, how do I in class? How do I usually pronounce equals? Like when you see me say equals, what do I usually? It's a boolean. It's a true false. So I usually say logical equals. So I say logical equals. But let me show you something. I miss Chadwick Boseman. That dude was awesome. I love his meme. We don't do that here. I've got one for this class. Same as code below. Same as code above. This right here is the same, and technically speaking, I guess I'll do it this way. And I would never do it these ways. I would not. I never code like this. Same as two above. Yeah. So all of these codes right here, let me show it just all three of these on the screen. All three of these codes will achieve the same goal. All three of these assign you, the character you, to the object character. It seems like char, but it's character, is what we're trying to save right there. Does that make sense that all three of these achieve the same objective? I don't like using equals for this. I like using left arrow. It's just that it comes down to personal preference. Someone could code this way, but all three of these achieve the same objective, but then this one right here does not achieve the same objective. This is going to save into. So if you look at this code right here, what's another way to code this? Like, how would Brian probably code this? How would Brian probably code this? How would Brian probably code this if Brian was coding this? Which is, it's all right. Yep, I would do that. So this code right here will achieve the exact same objective as, and I usually put spaces, but don't worry. Everyone, and just like you code right there, Kayla. So that code assigns 5 to the value of x. It's just coding preference. And probably everyone's going to be using equals now since Datacamp mainly uses equals. Dr. Petrie taught me left arrows, so yeah. But what if in an if statement? Oh, good question right here. So we'll do ifs, and then we're going to hop to Ella's question. Let's do this. So with if right here, the way an if works, which is in the intermediate R, which we're probably going to do a lot of that today, when you do char equals u, which it currently is, you then have code brackets right here. These are code brackets. These are function parentheses. These are code brackets. And this is the code that runs if this evaluates to true. So inside of an if, this is big. Inside of an if, you must put a singular logical. Does that make sense? Whatever is inside of here must evaluate to true or false. Does that make sense? Because you're not, inside of the if, you're not assigning something. Inside of the if will exist a singular true or false. So the code right here, the reason we have this, evaluates to a singular true. And we could put code right here and we could say paste, or if I'm going to do it, I'm going to do cat paste. And I'd say the letter is U. And that will paste the letters U. But now I could go right here and say else. And else also runs code. And I should be fine if I do this. I'm going to copy this and put this right here and say the letter is not U. Now the else isn't going to do anything right now because it's not evaluating to false. But if I go back up to character and I put in B for Brian, it's going to then evaluate. Oh no, did I not save it? What is going on? Oh, I did a logical test. Haha, haha. I forgot that was a logical test. There we go. When your code doesn't work, you got to be like, what did I do wrong? Does that make sense? Now it's going to run the else, and else runs code. So read this, else run this code. So when you see the curly bracket right there, and I'll drop some curly brackets in the chat. So if is a function that takes a true or false and then runs code via the brackets. So whatever inside the brackets is the code that will run if the if evaluates to true. An else can be tagged on the end of ifs to then run code if it evaluates to false. So because this right here now evaluates to false, the else will run. So because this evaluates to false, the else then runs whatever is in the else bracket. So if this is true, run the code inside of here. If it is false, that's where an else comes into play. So else, in the false case, run this. Does that make sense right there, Kayla? Hopefully that helps with And these are the kind of questions I really want today, like, because do we need x equals 5? So in an if statement, which one of those would you use? So in an if inside of here, which of those would you have? So if we're doing the number 5 and we do something like the number is 5, what would you have? Which of those would you have for inside the if right here? Yeah, it will be the equals equals, because the equals equals is going to do a logical test. So when we do something x right here, that'll run the number is 5. Because, and here's the way to know it's going to work, is if you highlight this code right here, it should evaluate to a true or false. If you were to have something like this right here, that's just assigning the value. So if you notice when you run it, the if has to have a true or false inside of it to run. So you can just highlight and be like, oh, that doesn't return a true or false. That's not what if takes. If must take something that returns a true or false to run. So if needs this true or false. Remember, we code in little bits. That's what we do. We make sure the code works, because an if needs a true or false, and then we worry about what code will run. And so just remember, I did all these in little bits. But that's great. I think Ella had a question. Awesome. Great job, Kayla. Have fun in class. For quote, quiz 4, what exactly determines if it is skewed or symmetric? Like, is there a specific quantitative or more relative? Oops, sorry. Which specific one are you wondering about here? Which specific one are you wondering about? Which specific one are you wondering about? The way to tell if it's skewed or symmetric. Question 1. Okay, cool. Tell me parts of the question if you can, because question 1 can vary. Basically, they mix up, because this is chapter 4 quiz, right? If you can read off to me any part of the question, they'll change up what the question order is. So if it's like a group of students do this, or a pizza parlor is doing this, here's my question 1 to start. And then let's see what the very start of the question is. So, because they'll randomize what your question is. What is the start of the question? Let's see here. 320 regression. Baseball. Let's do the baseball one. Okay. Baseball question. Is this the one? That doesn't look to be it. We're going to find the baseball question. Gas companies. Baseball teams. Is this it right here? I think this has it. This looks to be the baseball question. It's one of them. So here is the baseball question. Yep. Okay, we got it. You see the different order of questions. Okay. What I'm going to do right now is I'm going to take the data set and we're going to copy it right here, copy to clipboard, and let's take the data and we're going to bring it over to Jump. We're going to go to File, New Data Table, File, New Data Table, and then we're going to go here and go to Edit, Paste with column names, and now we have the data inside of our Jump right here. So with the data inside of Jump, it's actually a little bit complicated to display this one. So if you're doing this problem and you want to display it visually, you have to go here to Tables, you have to go to Stack, and you have to stack this and stack this. That was Tables, Stack. Here, I'll repeat it again. Tables, Stack. Yeah, no, that makes it a lot easier. And this one's, it's just complicated. You have to double click both those and click OK. And now we're good to go on displaying this. So now we have League A versus League B right here, and we have the data. So it's, we should have, double checking. Something seems wrong here. League A, League B. Did I not do it correctly? I really hate the way they have this data. You know what I might do? I'm going to do this. I'm going to make life easier. I'm going to change the data like this. Let's go to League, go to A, change, and just it didn't copy paste right. Okay, I might try to recopy paste in a second here. Okay, so here's the data fixed up, and let me try the other way here in a moment, but I just want to make sure we do it correctly. Okay, this is the way the data should be right here. We need a categorical and we need a quantitative, and let's go here to the fit Y by X. We're going to put right here league as the X and average runs as the Y, and I'm going to redo this graphic here in a moment once we get it, and we're going to go to the quantiles. And we're going to go over to quantiles. That's what I said. There we go. And we can see that there's no outliers. This is going to be a big help right here. There is a median here and a median here, and the upper point is not an outlier. So the upper point is not an outlier. That's a huge hint. And so it has to be between one of these two, and there's no outliers. So this is the answer. When we graphically visualize it, we can see, let's go to the graphic again, that there are no outliers. This D1 right here has an outlier, B has outliers, and A has outliers. So there are no outliers. Because of that, that makes answer C the choice. So we have found the answer. Write a few sentences. Okay, so we're going to see if it's skewed. We can now look at this graphic right here. Which way is the whisker pulled out on distribution A? Which way is the whisker pulled out on distribution A? Like, which whisker is pulled out a little bit more? Which whisker is pulled out a little bit more? The high side or the low side? The right side. So that's going to be a little bit right skewed. We're going to cross our fingers on this one. The distribution of runs scored per game is skewed to the right a little bit for League A and mostly symmetric for League B. So if you look at League B right here, this whisker is about even. This whisker is about even. So this one has a little bit of a right skew because it's pulled a little bit to the high side. And this one's more symmetric. It's not perfect, but a little bit more. The typical runs scored per game League A is higher than League B. I think that's right because we look here. So League A is higher than League B, while the variation in runs scored per game in League A is what to League B? It's greater, it looks to be. If you look at the IQR right here, and even the range is greater. So we should have it is greater than. Scared on these. The two teams playing for the World Championships, League A, Team 1, and League B, Team 1, both were at the top of their respective leagues. Did either team score any unusual large numbers? Neither team scored an unusually large numbers. Yes. That's 100 right there. So let me try to do the data again, just so people can get tips and tricks. Once again, we're going to copy to clipboard the data. We're going to hit Control or Command C, and we're going to go into a new jump data table. And I'm going to get this to work without doing it the way I did it. File, New, and here's a big thing. Since there are column names, which of these are we going to pick? Column names or no column names? Which there are column names. Here's a hint. If you do it the wrong way, it'll look like this. If you do it the right way, it'll look like this. Make sure you edit, paste with column names. Start over if it looks wrong, because it's much harder to correct than to start over. And I was 99% certain that the quick way of doing this is tables stack. So tables stack. I'm going to click the wrong button last time. Tables stack, and we're going to stack. We should be able to stack these two. And the label right there should be the right one. I think it's all right. So we're going to go here to analyze, and let's go here to fit y by x. And then we're going to put label down here. We're going to put data up here. Don't worry about these. And then let's click OK. And I was doing it correctly. I just overthought it. I just don't like that this says average run game 2. So other than it saying that, and you can fix that really easily if you click on this column and you go to recode. So you could call this A and you could call this B, and then you can recode in place. And so you can easily recode that right there. So Jump's got some really quick ways to recode it. So I right-clicked right here. It's just you don't have to worry about that since you're just trying to make it look nice. Well, does that make sense right here, what I've done? Ella, slow me down if you're like, Brian, that went too quick. But that's just how to visualize it. And if you select the right visual, you can then get the answers. But the recode option allows you to recode it. And you always usually want to recode in place. And then once you recode in place, you recode, and you can just change all these right here. Really quick way to change it so it's correct. I think that's got it for that. What other questions are there? How did you paste the... Great question, Ella. So when you're inside of My Pearson, wherever My Pearson is, you're going to click this table right here and go here. Tell me if you're good on this. Are you good right now? Just put like a yes or a Y in the chat for you're good. I'll do this very slowly. Okay, good. We're going to copy to clipboard. Now here's the big thing. Hit Control or Command A. Control or Command A on a Mac, Command A on a PC, Control A. So once you've done this right here, you now have it copied. Now you have to go over to Jump, and you're probably starting Jump from about here-ish. Let me bring it up. Let me bring it to the main screen. You might be right here in Jump. You want to go to File, New, data table. I'm going to pause right here. Are you good with this? Go to File, New Data Table. File, New Data Table. There we go there. So now that we're in a new data table, we're just going to full screen it. Don't click inside the data table. Don't click inside of it. A lot of people like automatically click. Don't click. It's very common. I'll often when I'm telling people, I'm like, okay, open a new data table and don't click inside of it. This is most people's reaction to like, oh, I'm gonna like, because usually you paste. You want to like, it makes sense. We're gonna go to edit, and in this instance, we're gonna paste with column names. In this instance, you're gonna paste with column names because there are column names. If there's not column names, you will not paste with column names. So if there's not column names, you will not paste with column names, but because there are column names, you will. How do you know if there's column names? Well, you'll see them. You'll see the column names appear. If you paste incorrectly, it'll look like this right here. This is an incorrect paste on the right side. So this is wrong over here. If you see this, start over because it'll change the types of the columns. Fixing this is way harder than, yeah. It all went into one column. Double check this here. Let's check again. Ready? Go back over here and go to, make sure you go to copy to clipboard. Don't copy to Excel. Go to copy to clipboard. You might send me a screenshot so I can see what happened. Go to copy to clipboard and then make sure it's tab. Don't change where it says tab and then hit Control or Command C. And now that we have it copied, we're going to go back into Jump. And don't click inside of here. Whatever you do, make sure, because I think if you click inside of here sometimes, I think that can cause the problem. See, it wasn't letting me paste with column names. So we're going to go here and go to paste with column names. You might send me a screenshot or my top on Discord because that's weird. So you should, everything should look like this. Got it. Nice. Good job. Yeah, it's great job, Ella. It's so hard for me to like not see what's going on. And so like, I'm glad you figured it out. Great job, Ella. Let's throw 20 points at the end here. Ella, thank you for sticking out to the end and working these problems because it's really tough online. It was clicked on space, not tab. Oh, wow. Yeah, good thing. That's why I like went back and like mentioned like, okay, make sure it's tab. Maybe at one point that had been selected. I usually think it's tab by default, but tab delimited works the best. So thank you everyone for staying till the end of office hours and just practicing. And hopefully, you know, if you know how to get data into Jump, it makes life easier. Yeah. Any other last questions? We covered a lot today. A lot of great help from people. Vols help Vols. That's what we do. I'll be teaching BS 320 here soon. Went out and caught some Pokemon this morning. Why can't I change the brightness of my phone? There we go. There we go. I was like, I lost power on my phone almost. Went on a long Pokemon Go walk. With that, let's put on a little music here and let's go to space. Let's put on... See, I like this. It's like nice and relaxing. So, any other last questions to end office hours today? What are people thinking? Let's see if there's any Pokemon around me. No Pokemon. Whoa. You're welcome, Ella. You're welcome, Leslie. If you could choose any place in North America to take a family vacation, where would you go? Great question, Andrew. You know where I'd like to go back to New York City. I wish Chelsea and I could just go to New York City, eat some New York City pizza, see my uncle, see my cousins up there. I've got lots of cousins around there. I've got so much family around New York City. My uncle works in New York City, and hope he's doing well with all the craziness. But maybe Boston, like the North. So I think it'd be fun to go to Boston. Such an interesting city. I've been there one time. Now that I've got like more money and like I was old enough to drink back then, but you know, just be like, yeah, let's just gotta account for young and old people. Oh wait, a family vacation. Well, my family's me and Chelsea. Okay, family vacation. You see, you could go to New York City with my family because then you could visit family and you could just like leave them. I think New York City. I'm going with New York City, Andrew. As my background messes up. Leave them. Yeah, well, yeah. Like my nephew Tolliver, he's how old is he? He's 5 now. And so you can just be like, oh, you're gonna stay with Aunt so-and-so or so-and-so, or like, you know, they're gonna watch over you. So I was thinking Canada. Canada be fun. My dad's from Canada. I am first generation American on that side of my family. I think second on the other. Sorry, maybe third. Yeah. My family has not been here for that long. On one side, I am the... What would it be? Let me think about this real quick. Mark, Darren, Brian. On one side of my family, I am the third person born in America out of like everybody. So like for the Stevens, I am the third Stevens born in America. Am I the third oldest of those cousins? Man, I never realized how old I am. No, I forgot Cindy. I'm the fourth oldest. Sorry, Cindy. She watches these videos, I'm sure. She's a teacher too. I'm gonna start stalking my cousins. No, but I'm the fourth oldest. I was like, wait a minute. There's Cindy, Darren, Mark, Brian, Laura, Kevin. Yeah. So with that, I'm second gen on my dad's side. Mom is adopted, so I have no idea. Yeah, actually, you know what's interesting is my grandma's adopted, but she's Canadian. So with my grandma being adopted, we really don't know, that line of our family, like where that goes. And then my grandfather came over here because of World War II. So he was, we're Jewish on that side. And so the music ends that abruptly. That's not. Music should not end that abruptly. Songs should always fade out. World War II. Yeah, we immigrated here because bad dude in Germany, Hitler. I'm like afraid to say his name, like it's gonna the video is gonna get like taken down. Yeah, bad dude. So I don't think people realize that. It's like a lot of different heritage. Like my German part of the family was, my German side is the side that was fleeing Germany. So that's my heritage on that side, the side that was like fleeing. So but yeah, no, and we were Schwabacher. He was Manfred Schwabacher. I don't know how to say his name properly, probably. But that's my grandfather, Manfred Schwabacher. And he changed it to Fred Stevens. Manfred Schwabacher, Fred Stevens. Makes perfect sense. So Manfred, Fred, Schwabacher, Stevens. So that's the German translation of it. I never got to hear him speak German, but he spoke German until he was like 18, 19, 20. Like he grew up speaking German. They went to Canada, and that's where he learned English. I can't imagine, can you imagine, when he got to Canada, how much English did he know? I bet very little. I'm from the Ukraine. It was a part of Poland, but not anymore. That's actually my other side is Polish. Czechoslovakia, which I don't think Czechoslovakia exists anymore. It's like Czech Republic? I don't know. I don't know the world. There's know that my side of the family, or both sides, just got here a little while ago. And that's fine. I love that. So, big melting pot. That's the way America should be. So I think it's very interesting. A lot of people might not realize that I'm first generation on one side of my family. Stevenses have not been here that long. As my background breaks. With that, Andrew, we'll be back tomorrow. Andrew, thank you so much for swinging by, having this chat at the end, just chilling out. Check this out. Outro screen now plays through the music. Bye for now. Bye. I can still talk about the music.